All right, so if I do this reaction, so if you watched the last video, that was base catalyzed formation of an hemiacetal. Here we're going to do the same final product, but in this case, do the acid catalyzed version of that. So if we have a reaction, same way with ethanol as our starting point, if we add some acid to that, say HCl, then these two things can react. Right? So that'll do a proton transfer and make a protonated alcohol. Right? So this is a strong acid now. So if we're doing a reaction and we want to add ethanol, this is generally where it's going to react first, right? And then our mechanism will start from there. Right? And so this is now a strong acid. That's a good proton donor. So it's not going to act as a good nucleophile, though. Right? It's got this positive charge here. It wants to give up that plus charge. It's going to want to act as an acid. You know, where is a proton going to go on this new structure? How does that help us? Right? So I've got two lone pairs up here. First step of the acid catalyzed version is proton transfer. Separate these out here. Right, so if I've done that, right, I'm back to a regular alcohol here, and now I've added a proton up here. So how does that help us? Right, essentially this is activating this group. So instead of a ketone, which is relatively neutral and not the strongest electrophile, I've activated that by putting a proton up there. And so what it really wants to do then is balance out that plus charge. So even a weak nucleophile in this case can bond here, because then that'll break the bond up and neutralize that plus charge. Right, so now I have my OH group there. I've also added this alcohol, which now would have a plus charge. So remember, we've seen these kind of patterns before. Oxygen with 3 bonds tends to have shared too many electrons, so it's got a positive formal charge. This is a different looking structure, but it's still oxygen 1, 2, 3, oxygen 1, 2, 3. Formal positive charge there. So if I were in class, I'd be like, all right, so what do we need to do next to finish this reaction? And you'd say proton transfer, and you'd be right. So let's do a little weird one just to keep it on screen and go down. Proton transfer is probably going to happen between solvent again or another alcohol reactant. Swapping places. All right, and now I'm back to hemiacetal. And my alcohol, which I slid off screen there, sorry about that, is going to form H3O plus again. Or sorry, the protonated alcohol that's similar to H3O+. So then I've got it back again, right? So I started here, ended here, right? So it was a catalytic acid. You don't need very much. But that is the mechanism. Let me frame it up a little better. And it's the same as what's in the notes, right? So if you're looking at the notes and you're like, what is this thing? This is the mechanism with a little bit of added extra explanation, right? And to not completely leave out our furry friends, there's the dog. Hey, Dobby. And my chemistry cat. Hey, Pico.